Welcome to day 6 of our 15-day beginner data science sprint. So far, we have learned how to load data, inspect a data frame, select columns, filter rows, and create new columns. But before we perform any serious analysis, we must answer an important question. Can we trust the data? A chart may look professional, the code may run without errors, the calculated average may appear precise, but all of these results can still be wrong if the underlying data is dirty. Real-world datasets frequently contain missing values, duplicate rows, extra spaces, inconsistent category labels, numbers stored as text, invalid entries, mixed date formats. Today we will learn how to detect and repair these common problems using Pandas. Imagine that our dataset contains the following gender labels. Let me share the collab. So gender labels are like this. So sometimes it is male, sometimes a M, sometimes another value with an extra space around it. To a human, these may represent the same category, but pandas may treat them as four different values. Similarly, imagine that the attendance of the same student appears twice. That student may be counted twice while calculating averages or totals. This is why data cleaning is not an optional step. It is a fundamental part of the data science workflow. The basic workflow is ask a question, collect data, clean it, explore it, analyze it, and communicate the result. So this is the basic workflow. Today we are focusing on cleaning stage. Let us begin by importing pandas. Now we will deliberately create a messy student dataset. So let's start creating it. So data equals the first in the curly braces we are defining the dictionary. So first key is student ID with these values. Then next is name, and names are with these values. Then comes the gender. Gender will have these values. Then comes the attendance. It will be having these values. Then the exam date, and finally the final scores. So this is our data set. This is our data. Now we need to make it as a panda data frame. So we write this command. We write this code and then finally display the DF. So let's run it. Now pause and look at the data. What problems can you already identify? So you may notice student 104 appears twice. Gender levels are inconsistent. Some gender values contain extra spaces. Attendance contains blanks, percentages, words, and missing values. dates use several different formats. One date is completely invalid. In real projects, the problems may not always be this visible. That is why we need systematic checks. Let us first inspect the size and data types. Before running the cell, what do you expect the shape to be? We created 8 rows and 6 columns. So the shape should be 8, 6. Now look at the data types. The attendance column will probably appear as object rather than a numeric type. This happens because the column contains values such as 72%, 80, blank text, none. Pandas cannot treat the entire column as numeric when incompatible values are present. The exam date column will also appear as object. So this you can see. This means pandas currently see the dates as text rather than proper date values. An important lesson is a value that looks like a number or date to us may still be stored as text inside the dataset. We can count the missing values using print df.isNA.sum. So the attendance column contains none. So Panda should detect at least one missing value. However, notice something important. The empty strings in the gender and attendance columns may not be counted as missing. An empty string is still a string. Therefore, this output does not prove that we have found every missing value. This is a common limitation of a basic missing value check. To handle blank strings, we can replace them with pandas missing values. So df.isNA is not sufficient. We use this command. df equal df.replace, and inside that we write the empty string to replace with NA, and then we do df.isNA.sum. So this time it gives us better values. The regular expression identifies values that are either completely empty or contain only spaces. After this replacement, pandas can properly recognize those blank entries as missing. This demonstrates an important principle. Missing information is not always represented in the same way. It may appear as none, NaN, an empty string, a dash, Na, not available, unknown. Before cleaning, we must understand how missing information is represented in our particular dataset. Now let us count duplicate rows. So let's write, and we must take the habit of writing Python, else we won't be able to learn it. It is very important to write code. So I will, just for demonstration, I will write the code here by hands, not copy pasting, not generating, but writing it by hands. So this gives me duplicate rows equal to 1. Because student 104 appears twice with exactly the same information. Therefore, we expect one duplicate row. We can inspect the duplicated records using, so you need to write the code, but I will paste the code. Display df.duplicated keep equal to false. So we get to see the duplicated rows. The argument keep equal to false displays every copy of the duplicated row. Now we can remove remove exact duplicates by this code. So df equal to df.drop duplicates, and then we copy again. Our dataset should now contain 7 rows instead of 8. But we must understand what this operation does not prove. Drop duplicates remove rows that are exactly identical. It does not automatically detect situations such as the same student appearing twice with different attendance values. Two people sharing the same name, a student ID being entered incorrectly, slight spelling variations in a name. Those cases require additional investigation. Therefore, duplicate removal should not be performed blindly. We should first identify the duplicate exists and whether it really represents the repeated information. Now let us inspect the unique gender values. So dot unique helps us identify that. Before we are saying this these values to standardize the text. We will remove extra spaces and convert everything to lowercase. So we will do this. Df gender equal to df gender dot str dot strip dot str dot lower, and then we are printing the df gender dot unique. This converts values such as male with capital M and male with small m into the same level. However, M and F are still different from male and female. So we can create a mapping. So first let's run this code. So we are getting 5 different values. Now let us create a mapping. Then we replace the gender column with the gender mapping. Now we print the gender column and we don't drop the NA by writing this drop NA equal to false in the parenthesis. We don't drop the NA column or none column. So let us see what is the value count now. So it is saying that male is 3, female is 3 and NA is 1. Now the category levels are consistent. For the missing gender values, we should not guess the student gender. Instead, we can preserve the missing value or use a document label such as unknown. For this demonstration, we will use unknown. This does not mean that the student gender is actually unknown in reality. It only means that the information is unavailable in our dataset. That difference should be documented. Let us check again. Let us inspect the attendance column. So let's print df attendance dot to list. The column contains numeric looking strings, a percentage sign, missing values, the word 80. Before converting the column, we should remove the percentage sign. So we will write df attendance equals df attendance dot as type string dot str dot replace, and there we are writing mod by empty, and we are writing regex equal to false. Don't consider this as regex. Then we are doing str dot strip to remove the extra spaces at the end. So let's run this and print df attendance dot to list. So let's run this cell again, and now we can see that the string are better visible. Now we can convert the values into numbers. So for that, there is a function dot to numeric, and there is errors equal to coarse. Now I don't understand what this means. So maybe I can ask ChatGPT or Gemini, or what is the meaning of this. So let me see if there is an option available to ask from Gemini. I will open a new cell. Okay, there is an option. Explain code. I'm using the Gemini 2.5 Flash model, and I want to understand what this error is equal to coarse means. So this code converts the data frame attendance column into of the data frame into a numeric data type. The pd.to numeric function attempts to convert each value in the column. The error is equal to coerce. Argument is crucial here. If any value cannot be converted to a number like 80 or empty strings, it will be replaced with NaN, not a number, which Pandas often represents as pd.na or its nullable d types. This helps in cleaning up the column for numerical operations. So let us now run this and let us see how the list looks like. So all the non-number values are converted into NA. So this error is equal to course argument tells pandas try to convert every value into a number. If a value cannot be converted, replace it with a missing value. Therefore, the word 80 becomes missing because pandas cannot safely assume that it means the number 80. Let us inspect the result. This is safer than manually guessing what an invalid value means. In a real project, we might return to the source and verify the correct attendance value. We now need to decide what to do with the missing attendance values. Possible strategies include removing the affected rows, replacing the missing values with the mean, replacing them with the median, replacing them with the most common value, keeping them missing, investigating the original source, or using a model to estimate them. There is no universal best strategy. The correct decision depends on what the variable represents, why the value is missing, how much data is missing, the purpose of the analysis, whether replacement could introduce bias. For this small demonstration, we will replace missing attendance with the median attendance. First, let us calculate the median. Now we can fill the missing values with the median. Let us check the column again. Why did we choose the median instead of the mean? The median is less affected by unusually high or low values. However, this does not mean that median replacement is always correct. It is simply a reasonable demonstration choice for this lesson. We must record this decision because filling missing values changes the dataset. So we must record this decision. Now pause the video here. Without using technical jargon, explain the most important change we just made in one sentence. A possible answer is we replaced unavailable attendance information with a typical attendance value so that the column could still be used in the analysis. Notice that this sentence explains the meaning of the operation rather than simply naming the pandas function. Our exam dates are currently stored as text. Let us convert them into proper date values. Here format equal to mixed allows pandas to process different date formats. Day first equal true tells pandas that values such as 1206 slash 2026 should be interpreted as 12 June. Errors equal to coerce means it converts invalid dates into missing values. Let us inspect the result. The value invalid should now become a missing date. This is useful because invalid text can no longer silently behave like a genuine date. However, converting the column does not prove that every date is historically correct. For example, a date may be valid in format but still be the wrong exam date. Date type correction checks structure. It does not automatically verify the truth of the information. Cleaning also includes checking whether numeric values fall within reasonable limits. Attendance percentages should normally lie between 0 and 100. So I will try this and display invalid attendances. So it is DF and in square brackets tilde DF attendance dot between. This means not. That is DF in attendance. The attendance is not between 0 and 100. Those are stored in invalid attendance. So let's display it and we see that there is no invalid attendance. Similarly, if the final score is out of 100, then we can check invalid scores and display them. So there are no invalid scores. Both outputs are empty. It means that no values violated these particular rules. But an empty output does not prove that every value is correct. I am repeating again, because the outputs are empty, it means that no values violated these particular rules. But an empty output does not prove that every value is correct. A score of 78 may be within the valid range, but could still have been entered incorrectly. Validation rules helps us identify impossible or suspicious values. They do not guarantee complete accuracy. Let us check the missing values again. We expect the invalid exam date to remain missing. That is acceptable because we do not have enough information to invent the correct date. Now inspect the data types. The attendance column should now be numeric. The exam date column should now have a date time data type. Finally, display the clean dataset. We now have a dataset that is more consistent or, and more suitable for analysis. But remember, clean data is not automatically perfect data. Cleaning reduces known problems. It does not prove that every value is actually correct. Every important cleaning decision should be documented. I am repeating again, every important cleaning decision should be documented. Let us create a simple cleaning log. So let's write it one by one. Cleaning log equal to, this is an array. So first value is converted blank string into missing values. Then we removed one exact duplicate student row. Then removed extra spaces from gender labels. Then converted gender labels into lowercase. Then map M to male and F to female. Then labeled unavailable gender values as unknown. Then removed percentage sign from attendance values. Then converted attendance into numeric columns. Then converted invalid attendance entries into missing values. Then we filled the missing attendance with the median. Then we converted exam dates into a consistent date time format. Then we kept the invalid exam dates as missing instead of guessing them. then checked attendance and final score for values outside 0 to 100. So all these steps have to be recorded. Finally, we print them, and this is our cleaning log. A cleaning log helps other people understand what changed, why it changed, which assumptions were made, which problems remain unresolved. It also helps your future self reproduce the analysis. Your challenge now thus comes the learner challenge. Your challenge is to write a short cleaning log for this dataset. For every changes, you need to mention what the original problem was, what operation you performed, why the decision was reasonable, what limitation still remains. For example, problem can be, this is one example. Problem can be the attendance column contain text, percentages and missing values. Action can be I remove percentage sign and converted the column into numbers. Attendance must be numeric before calculating average, that could be the reason. And limitation is invalid values were converted into missing values, but the original correct values. Those values are still unknown. Try to write at least 4 entries. Do not simply write the names of pandas function. Explain the decisions in in plain language. So this is the a possible cleaning log could look like this. I don't know. Okay, so fine. This is how the possible cleaning log can look like. Change, reason, and limitation for each and every change. Now let's discuss common beginner mistakes. A common beginner mistake is to automatically fill every missing numeric value with mean. For example, df attendance equal to df attendance dot fill na df attendance dot mean. The code may run successfully, but successful code does not mean a correct decision. Before filling a missing value, ask why is the value missing? Is the missingness random? Is the variable numerical or categorical? Are there extreme values? How much data is missing? Will replacing it distort the analysis? Could we verify the value from the original source? Sometimes the correct decision is to fill the value. Sometimes it is better to remove the row. Sometimes the missing value should remain missing. And sometimes we must investigate further. So a suitable one sentence interpretation of today's output is we removed repeated records, standardized inconsistent labels, converted attendance and dates into usual formats, and documented the assumptions made while handling unavailable information. So today we gained the ability to repair some of the most common problems found in real-world datasets. We learned how to detect missing values, recognize blank strings, find and remove exact duplicates, standardize category labels, convert text into numeric values, parse with date formats, check valid numeric ranges, fill missing values carefully, document every cleaning decision. The most important limitation is that cleaning does not prove that the dataset is completely accurate. It only helps us identify and address the problems that we can detect. Before ending, answer these two questions. What new capability did we gain on day 6? We gained the ability to detect and repair common data quality problems before performing analysis. And second is which output and limitations should you be able to explain without notes. You should be able to explain what changed after cleaning and why the clean dataset may still contain unknown or incorrect information. So in the next lesson, we will use cleaner and more reliable data to perform more meaningful analysis. Complete the challenge, save your notebook and write your file interpretation in one sentence. I will see you on day 7.